So I want to go over some preliminaries here before we get into actually solving some problems. So just these are the equations you'll need to use when you solve a problem involving head in the soil zone. So the first one is simply the definition of head. We said that head was equal to the elevation head Z plus the pressure head, which in general is called H sub P, the pressure component of head. And it is always equal to Z, that's elevation head, and the pressure head is always equal to P, the pressure, gauge pressure, over rho, the density, G. This is always true. So HP is always equal to the gauge pressure divided by rho, G. We can sort of demonstrate what this looks like in the saturated zone. Remember, that's not the unsaturated zone, but in the saturated zone, we have an example of let's point A right here in the saturated zone. And we can show that the head, the total head, represents the elevation relative to the datum, which in this case is that red line, elevation relative to the datum. So the total head is this. And it can be shown to be constructed out of the sum of the elevation head, which is the elevation relative to the datum of the point of interest, A, plus the pressure head now, in this case, is a physically visible thing. It's the height of the column of water. So we can see here that that long arrow H is equal to the sum of the two shorter arrows Z and HP, and that's this equation. That's this equation here, right? Now, in the soil zone, for example, right over here, if we wanted to do that same thing, this exact equation still applies, right? This thing is still valid. The only difference in the soil zone is that we don't define the pressure head as HP. We instead define it as the metric potential psi. It's exactly the same thing. So in the soil zone, we could write H equals Z plus psi, but really that is identical to what we did before. And psi, being the same as HP, is also equal to, we can write it up here as well, psi is also equal to P over rho G. Same thing. Now, the only difference in the soil zone, or the two important differences here in the soil zone, are number one, that psi is always, sorry, the pressure, the gauge pressure is always going to be less than zero. And so therefore, by this equation here, psi will also be less than zero, right? Since the pressure is less than zero and rho and G are positive, psi will also have to be less than zero. Now, the second big difference between the unsaturated and saturated zones is, unlike in the saturated zone where the pressure head was a physically visible thing, the height of the water in the column of water in the piezometer, you can't see it in the unsaturated zone. There's nothing to see and equate with the pressure head. It must be calculated from a measurement of the pressure. But it's got exactly the same interpretation. And once again, I can't emphasize enough, the equations you will actually need to use are essentially these two. H equals Z plus pressure head, which is called psi, and psi equals, just like it always does, the pressure over rho G. These are the two equations you will be needing to use to solve problems of head in the unsaturated zone. Now, one quick comment about the elevation here. This is the elevation relative to the datum. So in the example I showed over here to the right here, both the, well, just look at A. Okay, just look at the location of the input port right over here. Okay, this is above the datum, so Z is positive. Now, what would happen if instead, let me try to get rid of some of this here. What if I instead took and made my datum, let me get rid of this thing here too. Can I do that? Maybe I can't. What if I define my datum to be up here? So this is my new datum. In this case, the point A here is relative to the datum. It is below the datum. So in this case, Z, the elevation of point A relative to datum, would be less than zero. That means it's below the datum. So if the point is on the datum, z is 0. If the point is above the datum, z is positive. If the point is below the datum, z is negative.